All right. Welcome. Contrary to the title, I'm not providing any food, so sorry. I'm Sean. Yeah, if you want to walk out, I understand. If anyone does walk out, I'll just assume that's the reason why. My name is Sean McGinnis. I've been involved with OpenStack for several years now. I was the Cinder PTL for 4 releases up until Pike, and now I'm on the TC and just do general janitorial services. There's been a lot of work by the community recently to make Cinder available for broader uses. So I really wanted to get that message out there of some of the things that people might not be aware of. So hopefully we have some things here that are of interest. So to kind of baseline for everybody, what is Cinder? It's the block storage management service within OpenStack, but what it really comes down to is it's an API, a service that runs, that provides an API that can be used for doing storage operations, storage management operations, specifically block storage. It is an abstraction layer so that no matter what type of actual device is providing that block storage, your interface to Cinder is the same. It won't change. The consumer of this service, of this API, doesn't necessarily need to know what hardware is actually running in the data center. They just need to know how to interact with the API, and they get what they request. What it is not, and this is, I've had a lot of misconceptions and confusion about what Cinder actually does. It is not a storage provider. It does not provide the actual blocks that the data is stored on. So if you're familiar with something like Ceph, where you can take servers and install software and just run it, Cinder is not a replacement for that. It's not something where you install Cinder and that's what provides the block storage to your consumers. It is just the management of a storage system. It is not in the I/O path. One of the questions I've had is, okay, if I run Cinder, if I put it on an old machine, is that going to slow everything down? And once that volume is provisioned, Cinder's out of the way. At that point, it's directly between whatever your storage consumer is and the system that is providing those. And it is not an all-purpose storage manager. So there have been other systems out there to kind of broadly be able to manage storage devices and give reporting and nice fancy graphs and things like that. Cinder isn't something to accomplish that. Cinder has really a specific use case, and that is just being able to provide that API and that automation that an API gives you to be able to manage your storage or to provision your storage, and not necessarily something that is going to answer every storage management requirement that you have. So the typical use case, and what most people here are probably aware of Cinder as part of, is that block storage service within an OpenStack cloud. It works along with Nova, Keystone, Glance, and whatever other services you have in an OpenStack cloud to provide that block storage component. But a lot of work has been done in the community to be able to run Cinder in a standalone way, where if you're not running an actual full OpenStack cloud, if you just need that storage management API, you can just deploy Cinder. And typically Keystone is also required, but there's also a configuration option. If you set auth strategy, no auth, then you can just run the Cinder services themselves. You don't need anything else besides that. So we have some nice ways you can just deploy Cinder in a container and just run it by itself. So now, obviously, no auth is unauthenticated. So if you know that you're going to be running these services within internal, private subnets, just between the machines that need access to it, you know, no reason to have the authentication if you don't need it and you're trying to really pare things down to just the services that you require. So there's a lot of information about Cinder in general. These slides will be available later. So there's some kind of long URLs on there, so I hope no one's trying to scribble those down right now. But there's some good references here as far as showing how you can deploy Cinder in a standalone way, just general information and more details about what Cinder itself is and things that you can use it for. So as far as interacting with Cinder, and most people are familiar with Horizon, there's also the command line tools to be able to do just about everything. But there's also just depending on your use case and what your existing environment is and where you're trying to integrate these storage management services, you have a lot of options. There's various SDKs for many different programming languages. There's different command line tools. There's different config management systems like Puppet and Ansible, where there's been a lot of work done to integrate Cinder and block storage provisioning into those. So you don't necessarily have to think of Cinder as just an extra tab in Horizon. There's a lot of ways to access that, and I'm going to show a few here. I'm showing code, so hopefully that doesn't scare anyone. Even if you aren't a programmer and you're not familiar with scripting languages and things like that, I hope you can see that there's some things here that if you need block storage management in your environment for some other use case besides OpenStack, it really isn't too difficult to find examples out there and be able to integrate it in different ways. So to show a scenario, let's say you have a database, a production database, and you don't want to access that production data while your actual users are accessing it. But you need to run local tests against some of the data that's in the database. And I've seen this happen quite a bit where developers want to be able to try different things. Maybe it's database schema changes, maybe it's some new code that's going to access that data. And really having some sample data that the developers use. I've seen a lot of times where, yeah, it works great with a small data set that someone generated, but then when it's actually run against your real customer data, things fall apart. So a great way that people have done this, you can take a snapshot of that data, of your live production data, and then access it somewhere else where you're not going to interfere with what's going on with your actual mission-critical business. So the setup I'm showing here is Cinder, optionally Keystone, just to show how that Keystone integration works. My script will include authentication, and to really show that this isn't just an OpenStack thing, showing this with a Windows environment with SQL Server and PowerShell. So there's really a lot of flexibility here. So the example I'm going to show is using PowerShell, but this is an example of using the REST API, which you can access directly. Really gives you the most control. Pretty much all functionality is exposed through the API. The SDKs and CLIs have varying levels of availability to those APIs, but you can always go directly to the API. So for this, there's a long PowerShell script here, but there's a link on the bottom that you can take a look at this whole thing. It's quite long, so there's no way I can show it on the screen here and have it anywhere usable. But I'm going to jump into a few things here just to show how parts of this work. So first, since I'm using Keystone in this case, I need to authenticate. There's a nice commandlet in PowerShell called invoke web request. And it's kind of like curl if you're used to Linux environments. So I'm passing in some headers, and if you can see, method is post. So I'm posting some data against the endpoint. And then I need to authenticate, and I'm giving it an identity. So I'm telling it that I'm going to use password authentication. I give my username, password, domain, and the scope using the admin project in the default domain against the Keystone authentication. And when I get a response back from there, in the headers, this is the only really kind of tricky part if you're accessing the REST API directly, is you need to pull out X subject token out of the response and just include that in the headers as the X auth token for any subsequent things that you do. So like I said, you can do no auth. So if you're going to do that, you don't need to have this. You can just do the next step where you're just going against the sender endpoints. And once I have that, the next step is I use this invoke REST method call. And this is really it's very similar to the invoke web request that the last one did, but it's a really convenient commandlet in PowerShell where it can actually understand the JSON formatted data that gets sent back from the request, and you can just access those objects directly. As you'll see, I get a list of volumes, and then with the result variable, all I have to do is result.volumes, and I'm able to iterate through every volume that's being managed by Cinder. So it makes it really easy to, if you just need to pull out that kind of information, you can see here a couple PowerShell commandlets, and I get all that data back. So from here, I want to take a snapshot. I just tell it for the volume, sorry, I'm skipping over a little bit here because there's a lot in there. In this case, I have a snapshot, and I want to create a volume so that I can actually access that and use that SQL data. I do pass it, telling it to create a volume and use the snapshot ID of my existing snapshot. And that'll give me a new volume in Cinder. It'll actually go out to my backend storage, create a volume. And then I can call an attachment API. In this case, we're not attaching to a Nova VM instance. I'm just calling this attachment and getting the connection info. So this is where I can tell Cinder I want to attach my volume, and the response I get back, say if you're using iSCSI, it'll tell you what the target portal is, all the details if there's CHAP authentication, and then I'm able to use other commands like new iSCSI target to go on my initiator and actually log in and get access to that volume. And then once I have that, I can get the volume, I can do my commands, I can actually mount the data on that volume. So in this case, I had that SQL database data files on the production volume. I snapshot that volume, use that to create a new volume that I then mount up on my development machine, get that mounted in the SQL server, and then I can do whatever I need to do with that data without impacting my production. So if you're interested in any of these, there's some links to some of the PowerShell commandlets there. If you're using any other programming language, this last link goes to the API ref. Each OpenStack service publishes an API ref, and that's all the nitty-gritty details of each of the REST API calls that you would want to make. And so it'll give you examples of what kind of response you can expect to get back from that, what kind of status codes, things like that. So REST API is very powerful, but this should help you get all of the details that you need if you actually want to use that. So another way, so that's a commandlet directly going against REST calls. There's a lot of SDKs, different languages. One of the very popular ones with the community is the OpenStack SDK. And you may have heard of this as Shade. It's actually now, we took the 3 projects of Shade, OS Client Config, and the Python OpenStack SDK, and now it is one project called OpenStack SDK, where it combines a lot of the goodness of all these different things into one. And the really nice thing about this is a lot of it is driven off of a clouds.yaml file. So if you're in an environment where you actually interact with multiple different clouds, this is really cool. All you need to do, you create this file, you put in a list of clouds, and you'll see there under clouds, there's test lab. You can have multiple clouds listed, and this file keeps track of all of your credentials and things like that. So if you see that bottom line, as far as using this SDK, once I have that clouds.yaml file defined, all I have to do is just make a connection and tell it which cloud I want to connect to. So that really simplifies all of that authentication and all those details that we needed to do if we were accessing the REST API directly. So for this scenario, I'm going to show, say you have a gold image of a boot instance. In this case, I'm going to have it in glance. There's multiple ways to do this. You can keep it as a volume on your array and just clone that volume, or create a snapshot and create a volume from that. In this case, glance is a great service for keeping boot images, pre-configured data volumes, things like that. So wanted to include that in here. And for this case, maybe I have bare metal servers where I'm going to regularly deploy racks of servers, and I want to automate creating volumes using that boot image, and then maybe have something like IPMI that I can interact with the hardware and automate, bringing all of these systems up. Now, Ironic and other tools are also great for this, but if you're not using all of those OpenStack services, there's some flexibility here. So this is using the SDK. You can see, like I said, all I have to do is openstack.connect and just give it the cloud that I want to interact with, and that gets me the connection. And then I can create a volume. All I have to do is give it a name, a size, and tell it which image I want to use to create that. And then I have a volume. And then I can go on and do those other steps that I want to do to actually bring up my environment. Now, a little of this is forward-looking. If you're paying really close attention, you'll notice I didn't do the attach call that I had to do before in order to get the information of how to actually connect the volume. So this may work as is with maybe Fiber Channel if you have open zoning. If you're using iSCSI boot from SAN, the next or an upcoming version of OpenStack SDK will include the actual attach calls. So I wanted to show this, but there is a step missing here if you really want to tie all this together. The really nice thing about Shade and OpenStack SDK is they are very, very, very focused on ensuring backward compatibility. So even if you're running an older version of Cinder services, you can upgrade, grab the latest version of OpenStack SDK that's going to be coming out that will include these APIs, and you'd be able to use this no matter what version of the service you have. So any details on that? There's a lot of stuff out there about OpenStack SDK. If you aren't using Python, which a lot of people aren't, there are SDKs available for other programming languages. So there's Gopher Cloud is a big one in the Golang language, OpenStack for J, there's JClouds, there's a few other ones out there for Java. Pretty much most of the popular programming languages have some type of OpenStack client out there that you should be able to find. And if not, you can always fall back to that REST API. I also wanted to mention there is this greatly named Python Brick Cinder client extension on the bottom link there. That is an extension to the Cinder client that you can use that'll do some of these local attach information. So if you're looking at the scenario of being able to do a local boot from SAN or attach local volumes, there's some goodness in that that you may want to look at. Now, next one, say you have something that's running, you're kicking it off on Friday, it's going to take a long time, you really don't want it to end, to run into a out of disk space situation over the weekend and have to start over. So you want to automatically extend your volume if you're running low on space. Maybe not always the best practice, but sometimes we don't do the best practice. Sometimes we just have to get things done. So if you have something generating a lot of log files, you need it to run. In this scenario, I'm going to show you're using Cinder. you're running somewhere. Bare metal VM doesn't really matter in this case. You just have a volume that's being used, and you need to check and make sure that it doesn't run out of space. This is going to show how you can script the CLI with the OpenStack client to do some of these things. So I'm going to set up a script that gets called by a cron job to run every 15 minutes to do some things. I have the script source my credentials. So if you've used the OpenStack client before, very common ways, you have an RC file or some type of file that you source that's going to have your username, password, those types of things. And then I'm going to do some operations. I get the free disk space of my volume in question. Disk free -h. I do the -h because I want to operate in gig increments here. I don't want to figure out big numbers and figure out how close I'm getting. So I pull out the size and the space used out of the disk-free information. And then if I have a disk-free, if I have less than 10% of my available disk space, I want to then just use the OpenStack client, OpenStack volume extend, and just add another 10 gigs on top of that. Definitely, like I said, not something you want to run long term and keep growing your disk as you fill up. It could be very dangerous, but in certain situations, you got to do what you got to do. And then once the volume is extended, then there's whatever other local commands you need to run to actually get it to use that additional space. So that's a few lines of scripting to make sure that your job doesn't fail Saturday morning and sit there doing nothing until you come in on Monday morning and realize you got to start over again. And there's great documentation out there, Python-OpenStack client. It's got, of course, Cinder, but all of the OpenStack, most of the OpenStack services. It's a project still adding more and more support, but most of what you need to do in Cinder is included. Now, config management is, of course, a really great practice. I see a lot more people using things like Puppet, Ansible to set up their systems. Great way if you want to make sure all of your systems in your data center are configured in a good, consistent way. So an example I'll show is you're using that. You're using configuration management system. You want to include storage in your server setup, and you can use Ansible to interact with Cinder and be able to provision storage that gets mounted up on your server. So using Cinder should work on any Ansible supported environment and with an Ansible script. So Ansible provides some modules for Cinder. There is this OS volume. So I create a task. I'm creating a 100 gig volume, and I'm using the OS_volume module within Ansible to just give it some information. I'm saying I want this present. I want a 100 gig volume to be there, and it's giving the size and the information of what to call it, and then once I have that, I deploy this, or I run this playbook, it'll go out, it'll make sure that volume is present, and then I can use other Ansible modules to be able to do things like make sure that device is partitioned on my host and that it's got ext4 file system and it's mounted to /data. So all within my Ansible playbook, I can have everything defined here. And I don't need to worry about, okay, for this volume piece, I need to go out and script something special. Ansible includes that support built in to be able to do it. So there's quite a bit out there. If you've looked at the Ansible modules, they do all sorts of things. So if you need block storage along with those, this is a way that you can tie in with all those other modules to be able to set configuration to be able to do whatever your environment needs. And of course, www.ansible.com. A lot of great detail. I'd say if you're not aware of Ansible, check it out. It's a really powerful system. So hopefully I've shown some kind of made up scenarios here, but hopefully that's triggered some thoughts of different ways that you might be able to use this for your specific scenarios. I'd love to hear if you want to tweet anything to me of if you are already using Cinder for different scenarios. Let me know. I'd love to share that and learn about different ways that people are using this, or if you have a use case that you kind of have in mind and looking to see if anyone else has anything out there or anything like that, please definitely share that and love to hear about it. So that's all. If anyone has any questions, I can try to answer. Yep. How can I extend a bootable volume? That depends on the operating system. Some can handle that well and some can't. So you may end up needing to take an outage of actually rebooting that server in order for it to recognize it and use the extended space. But yeah, usually it's a little easier if it's not the boot volume that you're extended. It is possible though. No, not for, well, you can extend a boot, you can extend a volume through Cinder. Now, whether that's being used as a boot volume or just a data volume, Cinder doesn't really know. The tricky part is on the host side, and that's kind of outside of Cinder itself. You need to interact and do whatever needs to be done for that host, for that operating system, to be able to take advantage of the additional space.
It's been extended, but the operating system may not see that it's been extended. And that's the issue. That's outside of the scope of Cinder.
Yeah.
So you do the extension, the block device has been extended, but it's outside of the scope of Cinder for Cinder to make the OS see the extension. That's
so the question was around making that space visible to the operating system. There's no, I guess I should have pointed out, what's that? Not on the OS level. It really varies OS to OS how that's handled. Cinder doesn't run an agent or anything like that within each consumer of block storage, so there's nothing that Cinder can really do to automate that piece of it. It's there may be Ansible modules that can handle something like that. There's scripting that can be done. But you kind of have to refer to your given OS for recommendations on how to get a boot volume recognizing and using extended space. Yes?
As I understood, in future, one able to boot from a Cinder volume via, let's say, PC. And do you know so far if the Ironic project is also needed for this, or the Cinder plant project?
So the question was Pixie booting from a volume created through Cinder, right? Ironic does some stuff there. Unfortunately, I don't know enough about Ironic exactly to really go into depth about the capabilities there. But you don't necessarily need to use Ironic to do that. If you can create that volume and get that connection info, then you should be able to scripts automate the Pixie boot where it can connect and use that volume. Yeah, good. Any other questions? All right. Great. Well, thank you, everyone. And let me know if any questions do come up.